When it comes to the medical space, one important question is how can we use CFD simulation to support experimental therapies? For this simulation, we're looking at a ventilator that was originally designed to support a single patient, but we've bifurcated it to support two patients simultaneously. So the first thing we want to verify are how the pressures, flow rates, etc. are performing. So let's look at those flow rates. Here we're looking at the flow rates for all of the flow boundaries in our domain. We see an ascending ramp type pattern for 2 seconds coming from the ventilator on this red line, which then drops to 0 for the subsequent 4 seconds. At that point, the ventilator valve intake opens to allow for expiration. That corresponds to what we see in this plot. This is measuring the excess volume in the lungs, so 0 corresponds to the point immediately prior to inspiration. We see that the lungs are taking in about 700 milliliters of air, which corresponds with real patient data. Next, let's look at the pressure distribution. We're looking at the contours of pressure at a given instance of time. Not surprisingly, we see a large pressure drop associated with the connector in the mouthpiece. We also see that during inspiration, the exhalation hose is pressurized. This may explain the spike that occurred in the flow rate chart when the valve opens. So based on what we see in these data, it would appear that for two identical patients, bifurcating the ventilator disposables in order to support two simultaneous patients does not have obvious negative consequences. Of course, in the real world, patients are not identical, so further testing would be necessary before we fully understand the implications for safety.